All right, in this next section, what we're going to be looking at is rounding up all of the theorems and postulates we've been talking about throughout this unit. Remember, as we approach the BA exam, you want to make sure you have every one of these theorems known inside and out. That is to say, if I give you the hypothesis or the if part of the theorem, you can provide the conclusion. Likewise, if it has a name, you can identify it by name, both hypothesis and conclusion, so that you can basically have them memorized. For many of the theorems, the most important part isn't the name, it's the implication. So be confident that you're doing all that you can to know this material. Now, let's put them all together in one spot to make that studying just a pinch easier. Going back to chapter 2, there were a lot of rules we talked about in our review of systems of equations in order to do these algebraic proofs. Now, the important role these played has to do mostly with how we write the specific algebraic proofs to get us ready for writing the geometric proofs. To that end, I'm going to go ahead and review the core ideas. First, we had the properties of equality. Now, the properties of equality are used as part of the algebra work. All the properties of equality tell us that you're allowed to do something to both sides of the equation. So we have the addition property of equality. We have the subtraction property of equality. We have the division property. And the multiplication. Now, these properties each in turn allow us to do something to both sides of the equation. The addition property allows us to add, subtraction to subtract. If you're filling in the form below, what the basic format of these is going to be will look like this. For the addition property, it says if A equals B, then, and then there's a blank for us to fill in. And what we would write is A plus C equals B plus C. So we can see that we're going to be adding to both sides of the equation. And that will go with the addition property. For the subtraction property, well, that says we can subtract from both sides. So A minus C equals B minus C. For multiplication, we can multiply both sides by a value and not change it. So A times C equals B times C. And lastly, division. Now, division has one extra little quirk to it. And it's important to note for that quirk, A over B, oops, I want to do C. Again, we start with the idea that A equals B, so I can divide both sides by C. And there's one small extra thing that we should note, that C cannot equal 0 in this case. So these are the basic properties of equality that we talked about back when we learned how to do algebra. The substitution property of equality allows me to substitute for values in a given equation. So when we talk about substitution, this allows me to plug in for other values. So if A equals B, then B can be substituted for A. Oops, I want my other marker. B can be substituted for A. Again, that works off the assumption that A equals B. Not Ford. For A. All right, I'm done fighting that. For A. All right, so those are our properties of equality. Now, we also talked about the transitive property of congruence. This is kind of a not small deal. Transitive property of congruence. This is the one that allows us to cut out the middleman when we're dealing with things being congruent. So, for example, what the transitive property of congruence lets me do is to cut out that middleman and bridge ideas together. So, for example, as soon as there it goes, wakes back up. Where we usually tend to see this early on is when we're talking about segments or angles. So if I were to say that angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, I can conclude angle 1 is congruent to angle 3. If you're filling in the blanks, if figure A is congruent to B and figure B is congruent to C, then figure A is congruent to C. That would be the transitive property of congruence. Now, the right angle congruence theorem is pretty straightforward, and you don't see much of it. It says that all right angles are congruent to each other. They're all equal to 90 degrees. Mostly this one's there to give us something we can quickly prove, so we can cut 1 or 2 steps out of a proof later. And finally, the vertical angles theorem. We've been talking about the vertical angles theorem for some time. And on that one, we know that vertical angles, that is, angles formed by lines that intersect, are congruent to each other. So we know that vertical angles are congruent. And that's the vertical angles theorem. And that covers all the major theorems that we need from Chapter 2. Chapter 3's theorems, which are part of overall Unit 2, are a whole nother collection. We'll talk about those in the next video.